Hey, this is Bill in my glass shop again. This will be the fourth video in a series of, I don't know how many. Again, with unknown cameraman because we don't have any money to give him. But we're going to talk about the lathe again. And the lathe this time we're going to look at fixtures and setups that I've come up with and I've used through the years that possibly will help you. When looking at a glass lathe, to me, the whole thing is one, safety. As Noam used to tell us, there's nothing more important than your safety glasses. Didymiums, of course, quartz glasses. I like flip-ups. Flip-ups or downs for quartz. Please wear your safety glasses. And with a glass lathe, obviously, I imagine price determines the size that you can purchase or what you can do. When you can, if you can buy as big as you can, because when you have a bore, this bore happens to be, this is an EE, so I have about a 95 millimeter bore. You get fairly decent sized glass through there. And when you have something big, you can always make it smaller. Simple Jacob's chuck into your chuck, and now you're just as small as you want to be. With a lathe, of course, you need some tools. Simple graphite, paddles, round carbons, crazy big paddle if you need it. Fires. A lot of people like to mount a fire right here and use that. All I ever really used, that's the way I was taught, was bottom fires or cross fires, as they were called. This happens to be a 6-fire 7-jet. And I have it on a foot pedal with some relays on the bottom, solenoids on the bottom, solenoids to turn it on and off. That to me is very simple, very quick. And crossfires, bottom fires, whatever you call them, come in all sizes. This happens to be a 12-fire 7-jet. It's a little used a lot for quartz. This is an 8-fire single jet, which is also very nice, and they range in all kinds of sizes. Most of the time use a bottom fire in conjunction with something being held in my hand. This is a Hoke torch that I modified with a long neck because when you work with a lot of quartz, you want to get away from the heat. This is a Nortel with a big star fire on it. I believe this is a multi-mix. Seen better days, but still also a very usable fire. So you can use your bottom fire, use fire in your hand. That works very well. But let me clear these off, and we're going to get to this drag bar. And since unknown cameraman is on that side of the lathe, we'll keep him over there for the moment. Let's turn this off. Safety. You don't want to hit the pedal and have your arm right over it. But on my drag bar is what I call this assembly. I've assembled a stop that I can clamp and put in any position. And what that does for me is it will hold the tailstock in a certain position every single time. Very nice to have that if you need it. It's also adjustable. I put a Allen screw in it so that if I need finer adjustment, I can do finer adjustment on my stop. Let's have unknown cameraman come around a minute. And we'll keep looking at the drag bar. I've ganged up 3 carbons on my drag bar just because I had some different shapes I wanted to use. I didn't want to keep changing it, so I simply made 3. And it's a very simple unit. This one happens to be made out of a stainless steel bar with linear bearings. Linear bearings are nice because they not only traverse this way without really any drag, but of course they also rotate. And I found that linear bearings were kind of nice when I'm working with it. It won't move. I don't have to lock it in position until I'm at rest and move it. But as I said, drag bar, kind of nice. Put your work in. You've got your mold made, and you simply present it to the work and blow your shape. Lifts up and out of the way when you're done. Disadvantage, I suppose, is you need some room on the back of your lathe in order to have an assembly like this, but you can always make it shorter. I put it on counterweights, as I said, and that works fairly well for me. Let's take a look at something a little different. I call this a vacuum chuck. Vacuum chuck is, a piece of carbon mounted on a pipe, comes all the way out the tailstock to a vacuum system I have here with a valve. I'm going to plug this thing in. It's going to make some noise. And on this valve, I have it so that the pump is just pulling into this hose, rotate it, it pulls through this, rotate the valve again, it lets the piece go. So as we rotate it, it's now holding it. This is nothing more than a Pyrex watch glass. But we turn the lathe on, and you can use this kind of a deal to splice in or put on flat bottoms, put on round bottoms, hold any kind of a disc. As a matter of fact, let's release it. Very simple. It'll hold crazy shapes too. Now you may not want to rotate it in a crazy shape, but it'll hold a very crazy shape too, but only if it's flat. The watch glass, since it's a molded part, has a curve to it, but it's a very uniform curve, so it can be held like that. Vacuum chuck is a very nice tool to use, especially if you got big discs or something like that that you need to seal in. Let's turn this off because it makes too much noise. Now, let's switch a little bit. Let's talk about something else I had to make at one time. That's these. Sometimes you have to resize your tubing. Many times I've had to resize my tubing. Move the fire out of the way. Put these out of the way. This is nothing more than a simple holder. You got to drill a hole into here, so in order to get it to work. But you bolt that down on there, and it's nothing more than a carbon. It's held below your work. Now I didn't bolt it because obviously, well, that looks a little short. I have to get closer. Well, then you just use big spacers, whatever you can. Big spacer. Carbon comes up higher, you get closer. Also, this is nothing more than a little bracket I made. Threaded rod on rings to raise and lower the carbon. You can even do angles if you wanted to do angles. At one time, I was doing some 3-liter flasks. So I made that for myself. that's a 3-liter flask. The only problem with it was once you had the flask made, well, how do you remove the carbon, or what do you do? Carbon is held in with some pins. Pop the pins and pull the carbon. That was kind of a hot proposition, but that was what I did. So holder like that, kind of easy. At one time, I was making a lot of Allen bulb condensers. Now, Allen bulb condensers I was always taught that these Allen bulbs, to be as efficient as they can be, they need to be thin. If you collect up and blow, then they're not as efficient. But if you figure out the tubing that you want, the distance that you need, this was a standard condenser that I was making. All you simply do is go along and blow all of the bulbs into there and finish off however you want to finish off. And you have your set of Allen bulbs ready to go in and make condensers. Let's get rid of that. And we'll get rid of this in a minute. We'll go on to something a little crazier, at least something I needed that I made. This was a setup that I found very useful. A little strange, but useful. Lock your chuck like that, not a good idea. Always put in some kind of packing. Everything will release so much easier. And I found myself in need of having a joint mounted. I needed to drop it first. See how it's rolling. Rolling pretty straight. This is nothing more than a couple of O-rings on a taper that I made. Push the joint on. Might need a little adjustment to make it straight. No, that's not bad. But I found myself in need of, right when the glass was hot, it needed to drop, and then it needed to do this, so I could seal it from the side. And this is all adjustable so that I can get the proper drop for what I was doing. So let's change that now. That was a little wilder, a little crazier than usual. Let's go to something with collets. For people that need to do a lot of glass to metal sealing, collets are a godsend, I think. And I found a couple collet closers. And I found very useful. This is one of them. Again, I like to use packing. I really don't like putting metal to metal or just glass to the metal in the lathe. So this is a unit that I found here out of MSC J&L. It's a nice collet closer. In my other lathe that we're going to go to, I have this one. I actually put that in on a dedicated setup. But this was really nice. All you do is screw it into about the right distance using an Allen key, which is about the only place I use an Allen key. You're able to put the part in. Tighten it up. And actually straighten it up, because you have it. And now you can run straight. So even if your glass to metal is crooked, you can always normally tap it straight without a problem. Now let's take a look at another setup. This is a dedicated lathe. Always nice to be able to have a dedicated lathe where you set it up and you can leave it like that. But we'll have unknown cameraman John move. Oh, I said his name. Now I gotta give him $10. Damn. I'll owe it to you. Anyway, this is that other picture in that book I showed you. This is actually operated with a key. You gotta find the slot for the collet. Sometimes a little difficult. Oh, where are you? Where are you? There you are. Operates with a key. In this particular setup was dedicated to making these frames because I had to do put the flange, splice it sideways onto the tube. Anyway, you get that in there. This went in here in the correct position. I was also able to index it because the little set of holes that are here had to be in a specific spot. So I could index it correctly also. We won't get into that right now. But there we're held. There we're on. And there's one that's already spliced in the correct place. That was another setup that I made that was kind of instead of using straps or anything like that, I have fingers, and it simply comes out that easy, or goes in that easy. And held in the right position, blown through it. Of course now I've moved it, but very repeatable in a situation like this, where you've got a dedicated lathe. Most people would not be able to do that, but a dedicated lathe is something nice. But as we come all the way back here, we'll have the unknown cameraman. I won't say his name again because I already owe him $10. We'll have him come around, take this out. And I found that glass lathe is so versatile. You can use it for just about anything. I've even used it as a paint shaker.